We are no longer restricted to what our coefficients can be. Up until now, all of our examples, our coefficients have always been integers. That's what we're getting here. They can be integers, like we had over here. Our coefficients are numbers. Those are integers. They can be rational. You're missing what I'm talking about. It's by looking at your stuff. It's in there. It's on section 4. What does rational mean? They can be fractions. They can be radicals. Remember, I told you our first week of class, mathematics is a language. You have to know the language. We've been using these words all throughout the semester. What does a radical equation look like? The square root or nth root. It could be anything now. It can be real. It could be anything from negative infinity to positive infinity. Pi is a real number. E is a real number. It's constant. Or it could be complex. What's a complex number? What is a complex number? What's that? Right. A complex number looks like this. A plus bi. Every number is a complex number. It looks like this now. Our coefficients could be anything. We're no longer restricted. And again, also our degree is no longer limited to 1, 2, or 3. Our degree of our polynomial could be anything. What does that mean? What does the degree of the polynomial do? Very good. It's the largest exponent and tells us the maximum number of solutions we can have. Which leads us now to the fundamental theorem of algebra. We finally got to a point where we're now defining the fundamental theorem, the basic idea of what algebra is all about. fundamental theorem of algebra says this. Every polynomial p of x function of degree n, where n is greater than or equal to 1, has at least one zero in the set of complex numbers. What does that mean? Every polynomial function p of x of degree n, where n is greater than or equal to 1, has at least 1 0 in the set of complex numbers. Do you need more paper? You need more paper?
I have to bring.
I can give you some smaller paper. That's huge paper. It's up to you.
Okay.
I was going to give you like print size paper.
No.
Well, no, it doesn't have to do. It's not conditioned on the degree. Because it says it has to, in order to be a polynomial, what does it have to have? Well, in order to be a polynomial, it needs a degree. And the degree has to be 1, a linear equation or greater, has at least 1 0 that's in the set of complex numbers. What is the set of complex numbers? How do you mean?
The degree can be any, like any number. It can be it can be a radical.
Yes. Yes. What does a complex number look like? You're absolutely correct. Let's see if I can put it all together. What's a complex number look like? That's a complex number. Where a and b are real numbers. Every number can be written in this form. We talked about this when we first talked about complex numbers at the beginning of chapter 3. Is that a complex number? Is that a complex number? Is it the same thing? So this is a plus bi. What's a? A is 0. Is 0 a real number? Yes. So yes, this is a complex number. Is that a complex number? Is 0 a real number? Yes. So a complex number can have any form. I know. And that's why they said that. That's why the fundamental theorem says you'll have at least 1 0 that's in the complex realm. Yeah. If it's missing part of it, remember it has to be a plus bi. If it's missing part of it, that part's 0. And it's still complex. So So here is the next big part. Finding polynomials this chapter is I'm gonna give you large polynomials and you're gonna tell me all the intercepts. We're gonna start off with basics first. Let's work backwards. Remember how we learned quadratic equations and factoring? I first gave you the numbers and we multiply them together and then we worked backwards. We're doing the same thing here. So with there, you can jump into something ridiculous. We'll do the same thing here. X squared plus 5x plus 6. We set that equal to 0. It's in standard form now. We factor it out. We get x and x. The signs are the same. They're both positive. What times what is 6 when you add them? You get 5. 3 and 2. Then we take both of these, set them equal to 0, and solve. So far, so good. The stuff we've been doing all along. We were going from here to here. Now, I'm going to give you this, and you're going to give me this is what we're doing now. These are called what? X-intercepts, zeros, solutions, all these names. So if I give you, here, the saying we're going to find polynomials with given zeros. Find the polynomial p of x with zeros -3 and -2. All right. So this is my example. This question gives you zeros of -3, -2. How do we set that up in an equation? If there's zeros, how do we set them up? Nope, not yet. How do we set these up? You're saying x equals -3 and x equals -2. That's what it means there's zeros. They're my x-intercepts. Now, from there, I got to set them equal to 0 because they're my zeros. So I add 3 to both sides. I add 2 to both sides. So I have x plus 3 equals 0. X plus 2 equals 0. Those are my factors. Well, since they're my factors, I can take them and I can put them together. And they're still going to equal 0. Now I multiply. X squared plus 2x plus 3x plus 6, which gives me my polynomial. Do that, combine like terms. And there's my polynomial. I got my polynomial from the given zeros. Any questions about this? We're just working backwards now. All right, so let's pretend. Here's another example. Find the polynomial with the zeros 0, 3, and -1. Before we start, what do we know our answer is going to look like? What degree is it? What does a degree mean? It'll be 3 degrees because we have 3 zeros. The degree is the number of zeros that we have. In this last one, we had 2 zeros, so we're going to have a second degree polynomial. Since we have 3 zeros, we know our answer is going to have x to the power 3. And we know the graph. Opposite directions pointing up. So what's my first step here? Yeah, set all of these equal to x. We're working backwards. These are my solutions now. Then what? Make them equal 0. So here are my steps. First step, set each 0 equal to x. That's what we did, step 1. Then 2, set each term equal to 0. So we subtract 3 and add 1. This is already set equal to 0, so it's done. So we have x minus 3 equals 0, and x plus 1 equals 0. Then what? Multiply each set together. So we have anything set equals 0. I multiply them. Anything set equal to 0. Doesn't have to be an equation. It could be an x by itself. So we have x times x is x squared minus 3x. That's the first one. I did these two. To repeat the process, x squared times x is x cubed. Positive times positive is positive. X squared times 1 is x squared. Negative times positive is negative. 3x times x is 3x squared. Negative times positive is negative. 3x times 1 is 3x is equal to 0. Combine like terms. Positive 1 minus 3 makes it negative 2x squared. And there's my polynomial. Notice, since this 0 was a 0, which means that each term has to have an x in it. Because if x equals 0, what happens to each term? It goes to 0, so it goes through the origin. So just because it says 0 doesn't mean it doesn't exist. It means that there's an x in each term. There's an x in each term. And it's a cubic, so we're done. So far, so good. Another thing. with imaginary numbers. Our solutions, our polynomials, we don't always start off with imaginary numbers. Usually we never start with imaginary numbers. So if we have an equation that has an imaginary term in it, what would we multiply to that equation to get rid of the I, the imaginary? No. Nope. If we multiply by negative I, you still have a negative I here. Then multiply by its complex conjugate to remove it. What is a complex conjugate? Yeah, it's in your notes. Yeah, I think you never look at it. I'll let y'all find this one. Complex conjugate is where you change the sign in front of the X, or in front of the I. That's the complex conjugate. So the complex conjugate to 2x plus 3i is 2x minus 3i. You just change whatever sign is there, and that's the complex conjugate. Let's see what happens when you do the complex conjugate. 2x times 2x is what? 4x squared. Very good. Positive times negative is negative. 2 times 3 is 6. X times I is xi. Positive times positive is positive. 3 times 2 is 6. X times I is xi. Negative times positive is negative. 3 times 3 is 9. I times I is I squared. Combine like terms. The negative 6xi minus plus 6i, they cancel. What happens to I squared? What does it do? It changes the sign in front of it. So now we have no more i's. So whenever you have an imaginary answer, it has to come with its conjugate pair. The same with radicals. If you have a radical in the answer or in the statement, it has to always come with its complex conjugate. Radical 5 plus 2x. What's its complex conjugate? Well, again, just change the sign in the middle. It's always going to work out. Radical 5 times radical 5 is what? radical 5 squared. Positive times negative is negative. Radical 5 times 2x is 2x radical 5. Positive times positive is positive. 2x times radical 5. Positive times negative is negative. 2x times 2x is 4x squared. Square root squared becomes what? They cancel, so it becomes 5. The negative 2x positively cancel. Notice the radicals are gone. So whenever you have radicals or imaginary terms, you have to multiply by its conjugate pair. Must multiply by its conjugate pair. Or basically, it's just conjugate. What does that mean? Here's an example. Example 1. Find the polynomial of degree 3 with zeros 1, 3i, and negative 3i. So these are my zeros. What do I do first? Set them equal to x. Because they're my zeros, or my x-intercepts. Then what? Make them equal to 0. So I move them over. So I have x minus 1 equals 0, x minus 3i equals 0, and x plus 3i equals 0. I subtract a 3i and I add a 3i. Then what do? Then I multiply them together. So I have x minus 1, x minus 3i, and x plus 3i equals 0. Remember, we're looking for a polynomial equation, so we can't have parentheses. Since we have imaginary terms, let's multiply these together first. X times x is x squared. X times positive 3i is positive 3xi. Negative 3i times x is negative 3xi. Negative times positive is negative. 3 times 3 is 9. I times I is I squared. Then what? No. Once you multiply imaginaries, you combine like terms. 3 i's cancel. What happens to this I squared? It changes the sign in front of it. Again, review your notes for complex numbers. So I have x minus 1, x squared plus 9 equals 0. Now I can multiply these two together. I have an x minus 1, x squared plus 9. X times x squared is x cubed. X times positive 9 is positive 9x. Negative 1 times x squared is negative x squared. Negative 1 times 9 is negative 9. So rearrange these so they're in decreasing order. And so that's my polynomial. My polynomial is x cubed minus x squared plus 9x minus 9. Right, because a negative 9 and the I squared, all it does is change the sign of the number in front of it. So yeah, you say it's negative 9 times negative 1, which is positive 9. But no, it's it. Yeah, that's what we did there. Inside here, the negative I squared change the sign of the 9, so it become positive 9. And then when we FOILed this out, it became negative 9. Example 2. Now let's look at equations with multiplicities. Find the polynomial of degree 5 with negative 1 as a 0 of multiplicity 3, 4 as a 0 of multiplicity 1, and 0 as a 0 of multiplicity 1. How do we set that up?
X equals negative 1 is 0.
Okay, so we know x is equal to negative 1. What else do we know about zeros?
I mean, 1. X equals 1.
X equals 4 as a 0. These are the 0, that's a 0, and that's a 0. So x equals 0. These are multiplicities. These are not zeros. These are multiplicities. So what's our next step after this? Set them equal to 0. Which gives us x plus 1, x minus 4, and x equals 0. Now, where do the multiplicities come in? What are multiplicities? Above the parentheses. So the negative 1, 0 has a multiplicity 3. So this one is a 3. This one is a 1, and that's a 1. If we add up the multiplicities, they equal the degree, which is 5. So what this says, we have x plus 1 times x plus 1 times x plus 1 times x minus 4 times x. The easiest way to do this is by doing multiply these two together first. You'll get x squared plus 2x plus 1 after it's all said and done. These two will give you x squared minus 3x minus 4. Again, hope you should know how to multiply polynomials now. You could multiply these two together. We have 3 here, 3 here. 3 times 3 is 9. We're going to have 9 terms, combining like terms, before we combine like terms. So we have x squared times x squared is x to the 4th. X squared times negative 3x is negative 3x cubed. X squared times negative 4 is negative 4x squared. 2x times x squared is positive 2x cubed. Positive times negative is negative. 2x times 3x is 6x squared. Positive and negative is negative. 2x times 4 is 8x. And 1 times x squared is positive x squared. 1 times negative 3x is negative 3x minus 4. All that times 0. Does anybody not see where I'm getting these numbers from? Okay, so if you see where I'm getting them from, then I don't have to go through and explain where I got from. Combine like terms. X to the 4th, there's only one of those, so it's done. We have negative 3x cubed, 2x cubed, so it's a negative 1x cubed. So that's those guys. Negative 4x squared, negative 6. Negative 4, negative 6 is negative 10. Plus 1 is negative 9x squared. Negative 8, negative 3 is a negative 11x. And then negative 4. Again, combining like terms. So that's what I have here. So I have x to the 4th minus x cubed minus 9x squared minus 11x minus 4. And there's the x at the end. I still have a parenthesis, so I have to distribute. Multiply this x to each term. So that's x to the 5th minus x to the 4th minus 9x cubed minus 11x squared minus 4x. And all that equals 0. So all this x does is just add an exponent by 1. I did. Oh, look at. Yes. So that's my answer. It's x to the 5th. It's a 5th degree polynomial. It's just very long. So far, so good? I know. Again, it's not difficult, it's long. That's just the hard part about it. It's very long. It means a lot of writing, and the more you write, the more chance of mistakes. With what we talked about earlier. Find the polynomial of degree 6 with zeros. -2 plus 5i, -2i, and 1 minus radical 3. These are my zeros. And we're not going to work this one all the way out because it's going to be very long. All this was asking is find the, let's make it zeros of the polynomial of degree 6 with the following zeros. All I want to know is find me the zeros. How many zeros are we going to have? And put your phone away. You don't need to put your phone away. What's that? We'll need 6 zeros. How many do we have right now? We only have 3 zeros. So we're missing 3 more. How do we find those 3? Oh, okay, go ahead. No. That would be squaring the answer, which means, remember, what do we need to have whenever we have imaginaries or radicals? The conjugates. So if this is a 0, what's its conjugate 0? -2 minus 5i. If this is a 0, what's its conjugate? Positive 2i. And then the last one, since this is minus, it becomes plus. These are my 6. Those are my zeros. How would we set them up in an equation? Move all of these over to the other side. Oops. So this one would become x plus 2 minus 5i equals 0. That's 1, 0. That's one factor. Move this one over. So it becomes x plus 2i equals 0. That's another factor. Move this over. So it's x minus 1 plus radical 3 equals 0. That's another 0. And do the same for this. We have x plus 2 plus 5i equals 0. Move this over, so it's x minus 2i equals 0. X minus 1 minus radical 3 equals 0. So what did I do? For all of these, what did I do when I moved them over? Just change the signs. And that's why, now that since it equals 0, my polynomial will look like this. X plus 2 minus 5. Then it's x plus 2 plus 5i. That takes care of both of those. X plus 2i, x minus 2i, x minus 1 plus radical 3, x minus 1 minus radical 3. I'd multiply all these together, and that'll give me a polynomial. But I'm not going to do that. This is a lot of work. What's my degree going to be? Yeah, because this is polynomial the multiplicity, multiplicity, multiplicity. If I add up all those, it equals 6. So yeah, that would be just too painful. Example 4. Now this one's going to ask you to work it out. Find the polynomial of lowest degree with zeros, negative radical 3, 1 plus I, as 2 of its zeros. And so what's my degree of my polynomial going to be?
X equals
Now I want to ask you, what's my degree going to be? Listen to the question. 4. Because my zeros right now are what? Negative radical 3 and x equals 1 plus I. How many zeros am I missing? 2. I need 1 0 to be positive radical 3. I need 1 0 to be 1 minus I. So now I set them all equal to 0. So I have x plus radical 3 equals 0. That's one polynomial. And this one's going to be x minus radical 3 equals 0. That's my second one. X minus 1 minus I equals 0. That's my third one. X minus 1 plus I equals 0. So it'll be a degree 4 polynomial. It's asking us to find the polynomial, so we have to multiply these together. X times x is x squared, negative radical 3x, positive radical 3x, positive negatives and negative. Radical 3 is just 3. Those two cancel, so it's x squared minus 3. X times x is x squared, minus x plus xi, minus x plus 1, minus I, minus xi, plus I, minus I squared. So we have x squared. Here's a minus x minus x. That's minus 2x. Xi minus xi cancel. I, negative I, positive I cancel. I squared becomes a negative 1, so it becomes a positive 1. Positive 1 makes it a positive 2. Again, if you're just watching, that's great, as long as you understand what's going on. X squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. positive 2x squared, negative 3x squared, positive 6x, negative 6. So our polynomial becomes x to the fourth minus 2x cubed, combine those two, minus x squared plus 6x minus 6. There's my polynomial. Again, it's just combining a lot of these things we have already. Any questions so far? Yeah, the reason I'm going, again, I apologize. The reason I'm going so fast is because we're still just touching the stuff we've done already. The next half of this section is now we're going to start solving polynomials. We haven't worked on polynomials yet. We just showed where they came from. We haven't done the work yet. Again, all this stuff is reviewing the things we've been talking about. There's been nothing new presented here. Nothing new. Because now the next half is we're going to start looking at polynomials. I'm going to give you equations like this. You can't group those. That's not going to work. You can't move them around like we did earlier. That's not going to work. So let's figure out other ways to find out what are the four solutions. We know we're going to have four solutions because of that. We need to know these factors because we need to know the x-intercepts. The way we'll do this is we're going to focus on these two terms as well as the signs. And we have to know how to do synthetic division. So if you're not sure about synthetic division, review it, practice it. Because if not, this is going to take you hours to do one problem. And that's what we're going to start off doing tomorrow is we're going to look at those factors, those parts there, find all the possible factors we can get. And then we'll go one step further. Because remember, what we're trying to do here, remember what we did earlier is if I give you a polynomial, and if you put a number in here and it equals 0, then that's a solution, right? Then you know that x minus 4 is a solution. Or x equals 4, which is, this is a factor. But if we just did it this way, guess and check, how many numbers can we check? We have an infinite number of numbers to choose from. They don't have to be integers. They can be fractions. They could be rationals. They could be radicals. So there's an infinite number of solutions that way by guess and check. What we're going to do is by looking at these two guys, we're going to narrow that down to a small, like maybe 15, 20 possibilities. And then we'll go one step further by looking at the signs. I'm going to tell you the number of positive solutions and the number of negative solutions. And that narrows it even further because if you get 20 solutions, those are all positive and negative answers. And I know that I have no negative solutions, that just cuts your answers in half. So we're going to narrow down the possibilities of finding out what your answers are. That's what the rest of this section is about. Again, this one here is going to be the most difficult part. Has a lot of moving parts. which is why I beg of you, look over your notes over the last 4 days. Become familiar with what we're doing. Because I'm watching y'all copy what I did today, and you're writing like your lives depend on it. If you understand it, then it's not really that difficult. But if you don't, please review the stuff. Again, I'm sorry I went that fast, but remember, we're losing Friday. We're losing a day at the end of this week. So we need to get a lot more done a lot faster.